Consequences of hydrogen bonding. First one is dissociation. What do you mean by dissociation? Dissociation means splitting up of molecules or compounds or breaking up of molecules or compounds into its ions in the aqueous solution. This process is called dissociation. For example, HF molecule in aqueous solution dissociates to form HF2 negative ions instead of F negative ions. This is because of hydrogen bonding between hydrogen and fluorine, which is a more electronegative atom than hydrogen. It forms hydrogen bonds in aqueous solution and exists as a HF2 negative instead of F negative, and that's why the KHF2 molecule exists. This is the reason for existence of KHF2 molecule. Because of hydrogen bonding, the fluoride ions do not dissociate into water. They are not produced in water. HF2 negative ions are produced in water due to hydrogen bonding. HCl, HBr and HI, they do not form hydrogen bonds, and hence the molecules like KHCl2, they do not exist because HCl, HBr, HI, they do not form hydrogen bonding, because in this the chlorine, bromine and iodine, they have low electronegativity and do not form hydrogen bonds, and that's why the molecules like KHCl2, KHBr2, KHI2 does not exist. Next is association. Association is the reverse of dissociation, in which the molecules combined or mixed together to form aggregates or clusters in the aqueous solution. For example, in case of carboxylic acids, this is the formula of carboxylic acid. It exists as a dimer in aqueous solution due to the formation of hydrogen bonding. In this way, this carboxylic acid exists as a dimer in aqueous solution due to the formation of this hydrogen bonding. And the molecular mass of such compounds which exist as a dimer in the solution doubles the expected value or calculated value. This is due to the formation of hydrogen bonding. And the next consequences, next result of hydrogen bonding is high melting and boiling points. Like in case of water, HF molecule, NH3, ammonia molecule, they all have high melting and boiling point. This is due to the formation of hydrogen bond. Like in case of water, oxygen forms hydrogen bond with hydrogen because oxygen is more electronegative than hydrogen. Similarly, in case of HF, fluorine forms hydrogen bond with hydrogen, and in case of ammonia, nitrogen forms hydrogen bond with hydrogen. And due to covalent bond as well as hydrogen bonds, they have high melting and boiling point because melting point and boiling point depends upon the strength of the bond, and in this case the strength of the bond almost double because of covalent bond as well as of hydrogen bond. That's why they require more energy to break the bond, and hence their melting and boiling points are high and exist as a liquid and in solid form. But the rest members, like in case of oxygen family, H2S, H2SE, etc., they exist as a gas form. They exist in the gaseous form because the sulfur and selenium, they do not form hydrogen bonds and they have low melting and boiling points. And the next result, next consequences is solubility. The compounds which can form hydrogen bonds with solvent molecules are soluble in such solvents. For example, lower alcohols like methanol, ethanol, C2H5OH, etc. They are soluble in water. They are soluble in water because they form hydrogen bonds. They form hydrogen bonds with water. Suppose this is the C2H5 ethanol. Here it is partial negative charge, and this is the water molecule in which oxygen carries partial negative charge and hydrogen carries partial positive charge, and this bond is called the hydrogen bond. Due to formation of hydrogen bond between ethanol and water, it is soluble in water. Another example is of ammonia. Ammonia is also soluble in water because of formation of hydrogen bonds with water. Here it is nitrogen, and these are three hydrogen bonds. And this nitrogen forms the hydrogen bond with water molecule. This is partial negative, this is partial positive, and here it is partial negative charge, and this bond is hydrogen bond. And due to formation of this hydrogen bond, ammonia is soluble in water. And the next result is volatility. First of all, what is volatility? Volatility is the tendency, is the property of the compound by which the molecules have a tendency to vaporize, means it forms vapors. And the volatility depends upon enthalpy of vaporization. It depends upon enthalpy of vaporization, means change of a molecule from liquid state to gaseous state. The energy required to change the molecule from liquid state to gaseous state, that enthalpy, that energy is called enthalpy of vaporization. If the enthalpy of vaporization is less, it means the substance is more volatile. And if the enthalpy of vaporization is more, it means the substance is less volatile. For example, in case of PH3, ASH3, SbH3 and NH3, the enthalpy of vaporization, this is the increasing order of enthalpy of vaporization of the hydrides of nitrogen family. Here in case of PH3, it has lower enthalpy, least enthalpy of vaporization, and hence get vaporized easily. But in case of ammonia, hydrogen bonds exist. It forms hydrogen bonds, and due to this strong bonding, it requires more energy to change into the vapor form, and its enthalpy of vaporization is higher in its series, and it means it is less volatile. But PH3 is more volatile than NH3 because its enthalpy of vaporization is low, very low. Next result is viscosity and surface tension. What do you mean by viscosity? Viscosity is the resistance to the flow of fluids or liquids, and surface tension is the attractive interaction by the molecules in bulk. Suppose these are the molecules in bulk, and these are molecules on the surface. The molecules on the surface experiences the net inward force. This is the net inward force by the molecules in the bulk, which creates a tension on the surface, and that tension, that stretching on the surface by attracting the surface molecules into the bulk is called surface tension. And when the substance has hydrogen bonding, when the compound has hydrogen bonding, it means its viscosity is high. The compounds having hydrogen bonds are more viscous than the other compounds, and they have more surface tension than the other compounds. Next is maximum density of water at 277 Kelvin. At 273 Kelvin, water exists as a ice in which it forms hydrogen bonds and cage-like structure. Ice has cage-like structure due to formation of hydrogen bonds, and these occupy larger volume, and the density of the ice is low due to vacant spaces between the ice molecules. Upon heating, when we increase the temperature from 273 Kelvin, these hydrogen bonds starts collapsing, means breaking, and thus the molecules start coming together, resulting in the decrease of volume, which results into the decrease of volume, and hence the density of the water increases, which goes up to 277 Kelvin. After 277 Kelvin, the liquid water expands due to absorption of energy. Molecules get sufficient energy to get apart from each other, and the volume of the liquid water increases, and hence the density decreases. It means there is maximum density of water at 277 Kelvin. Lower density of ice. What is the reason behind the lower density of ice than water? In ice, the oxygen atoms are tetrahedrally arranged and form hydrogen bonds like this. This is the hydrogen bonds, and this, as a result of this, it forms a cage-like structure. This is a cage-like structure, and it has some vacant spaces in the structure. Due to these vacant spaces, the molecules of water are not so closely packed as they are in liquid, and this is the reason for lower density of ice than water, because it has vacant spaces in between the water molecules, which forms hydrogen bonds, which results into the decrease in density for the same mass of water.